this chapter we will be introducing you to a branch of mathematics called trigonometry. In this lesson we will be doing word problems with trigonometry. We will begin by looking at a couple of definitions.
Okay, so in the last couple of lessons here we've been talking about how to use trigonometry to solve for sides and angles in triangles. And then last lesson we even talked about solving a triangle, finding everything that you don't know. Now we're going to do your favorite thing ever. We're going to do word problems. So, before we get into solving word problems here and doing a bunch of examples here, because that's really what you need to see. You just need to see a bunch of examples, then you should get the pattern that's being established. Just a couple little definitions here. I need you to understand what we mean when we say angle of elevation and angle of depression. Okay? So the angle of elevation, when you want to think of it like this, if you were to stand and just be looking straight forward, and then have to tilt your head back to see something up top, above you, that angle that you would have to tilt your head back, that's going to be your angle of elevation. Okay? Just like the angle of depression will be, again, if you're looking straight ahead and then you have to tilt your head down to see something, the angle down from the horizontal will be called the angle of depression. Okay, so in both of these cases here, we're comparing the angle here is being built essentially from the horizontal. Okay, now let's just jump into some examples. Okay, so in this first example here, we read that if the kite string in the figure is 120 meters long, okay, so there we go. In this particular case, it's the hypotenuse here, 120 meters long. Calculate the height of the kite, okay, right here, and express your answer to the nearest tenth of a meter. Okay, let's zoom in on this a bit. So remember how we deal with trigonometry. The very first thing we want to do is get anchored on that angle. That's the angle that we're given. That's the one that's important here. That's what's going to define all the sides here. So once again, the hypotenuse is opposite the right angle. That's easy. In this case here, this is 42 degrees. This is our opposite side. So it turns out height is opposite the angle that we're looking for. And then this side down here on the ground would be the adjacent side. But I'm not given any information about that. I'm not being asked anything about it. That's not a relevant part of this problem. So, given this right here is the angle, I am looking for the opposite side and I have the hypotenuse. So let's just think about that. What trig ratio relates the opposite and adjacent sides to a given angle? And the answer is sine. So we know that this is going to be the sine of 42 degrees will equal the opposite over the hypotenuse. Now, remember, the calculator already knows what that ratio should be. So I just have to basically inform the calculator what angle that is, what triangle it is that we're working with. So that's the sine of 42 degrees. Now I already know this is just going to be a number here. So I'm going to leave that in there for now. I'll get to it later. I know the calculator knows it. I have faith. I'm happy. So I'm going to cross multiply here. 1 times h is h, and that's going to equal 120 multiplied by the sine of 42 degrees. Okay, now I can go to my calculator and figure that out. Okay, 120 times the sine of 42 degrees. And I can just enter this into my calculator in one step. Press enter. And I believe it says to the nearest tenth of a meter. Yeah, so to the nearest tenth of a meter, we get 80.3. So the kite is 80.3 meters high. Now let's just talk about this really quickly here. Do you need to have a sentence at the end of this word problem? Well, no, not necessarily a sentence, but I need something to indicate that you know what you just found, the significance of what it is that you just found there. Because there will be times, particularly in Math 20, when you will solve a problem, you'll get a value for the variable, but it turns out that isn't the actual answer that you're looking for. And so you're going to have to spend just a moment interpreting the result that you got. So I want you to get into the habit of interpreting your results. I need to know that you know what that number means. In this question we read that Bill is renovating his house. Oh, poor Bill. He braces a wall with an 8-foot wall brace. Okay, so in our diagram here, that's this right here. That's the hypotenuse. as shown, and the distance from the wall to the lower end of the brace is 2.4 feet. Okay, so that's down here. Calculate the angle at which the brace meets the wall. So that's the one up here. And so now let's just zoom in on this. So, whoops, wrong way. So here's the angle that we're interested in. So that tells us how we're going to label everything. That makes this, well, this was the hypotenuse right from the beginning, but that makes this 2.4, the opposite side. And then this one right here, because it's part of the angle, is adjacent. Now, I don't have any information about the adjacent. I'm not being asked for anything about it, so that's not relevant. So really the only relevant pieces here are the opposite and the hypotenuse. So I got to think, okay, what trig function do we know is that ratio? And the answer is sine. Okay, so the sine of theta, I don't know what the sine of theta is. I don't know what theta is. I don't know what theta is. But if I did, when I press the sine of theta, it would give me the ratio of the opposite and the hypotenuse, opposite of the hypotenuse. Well, in this particular case, I actually know that. I didn't need to know the angle to know what that ratio is. I can figure out 2.4 over 8. So now what I'll do is I will go backwards. I'll do the opposite, okay? And instead of figuring out the sine of 2.4 over 8, I will do the inverse sine of 2.4 over 8. And this will give me the angle that I'm looking for. So on my calculator, I will press second sine, and then this will be 2.4 divided by 8. Okay, and I get 17 degrees. Okay, so the brace and the wall meet at 17 degrees. There you go. All right, now in this question we read that Mary wishes to determine the height of the tree in her yard. Okay, this is a classic. Okay, I mean, this is a classic trig problem. In fact, this is such a classic trig problem. You'll see something like this in a Sherlock Holmes book, okay, where in one of the mysteries here he uses trigonometry, and it's about the height of a tree. It's always the height of a tree. So she measures the angle of elevation. Now in this particular diagram, that's got to be this guy right here. It's the angle up from the horizontal. So she measures that to be 25 degrees at a point that's 20 meters from the base of the tree. Okay, because that's easy to measure. Okay, you can just lay the measuring tape out. It's very easy to figure that out. It's also actually fairly easy to measure this angle of elevation here. So now the question is, how tall is the tree? Okay, well, let's take a look at this triangle. I keep going the other way. So here's the angle that's important here. It's the one that's given to us, and it helps us to define the sides here. This should clearly be the right angle. So opposite of that is the hypotenuse. The height of the tree is going to be opposite the angle that we were given, and the 20 meters here is adjacent to it. So now the two sides here that I'm interested in are the opposite side, that's the one I'm looking for, and the adjacent side is got information that I need. Okay, so h and 20 here. Now, what trig ratio do we know of that relates the opposite and the adjacent side? Okay, well, it's going to be tangent. So we know in this case the tangent of 25 degrees is going to be equal to that ratio. The ratio, in this case, of h over 20. They should be equal to each other. So I will go to my calculator in a second here to figure out what the tan of 25 is, to figure out what the ratio is, but I don't need it right now. I'll just make this over 1 and cross multiply to get the h by itself. So h times 1 is h, and this will be 20 times the tangent of 25. Now I'll go to my calculator. Make this 20 times the tangent of 25. Whoops, sorry. 20 times the tangent of 25, press enter, and we get 9.3. Okay, so what does that mean? Well, that means the tree is 9.3 meters tall. All right, this question here is actually, it's similar to the previous one, but we're looking for something different in this case. So Matt is 1.65 meters tall, and his shadow is 1.43 meters long. So we're going to determine the angle of elevation of the sun to the nearest degree. Okay. So here we go. So again, here's the angle that's important. Angle of elevation, remember, it's from the horizontal up. So it's got to be this one down here on the ground. We're assuming he's standing straight up, so that's going to be your right angle. And so here's the hypotenuse. But notice there's no information about the hypotenuse. It's either being given or being asked for, so that's not really all that necessary. His height is opposite that angle. And that 1.43, that side right there is being used to help build that angle, so it's adjacent to it. Okay, so now I think, which of my trig ratios here, okay, the trig functions here, involves opposite and adjacent? And the answer is tangent. So the tangent of theta, if I knew what theta was, when I entered tangent of that angle, it would give me the ratio of those two sides. I don't know the angle, but in this particular case, I do in fact know the ratio of those two sides. I can figure that out right away, just by plugging in those numbers. So I already know what that is, so what I really need to do is go backwards by using the inverse tangent. Okay, the inverse tangent of 1.65 over 1.43. And now I'll go to the calculator, and it'll be second tangent of 1.65 divided by 1.43. And there we go, 49 degrees, rounded to the nearest degree here. Good. So the angle of elevation, is 49 degrees. Excellent. All right, so in this question we read that Joel is flying a kite. He lets, actually it should be out. He lets out 150 meters of string, and using a clinometer, because obviously every child when they're out flying a kite carries a clinometer with them, measures the angle of elevation of the kite to be 75 degrees. How high is the kite above ground in the nearest meter? Okay, so what's going on here in this case is we have to draw this one out. That's what makes this question a little bit more challenging, is you really have to provide your own diagram. So here's the kite up here. We've got 150 meters of string that have been paid out to hold onto the kite there. And then he measures the angle of elevation here, the inclination here, and that's 75 degrees. Now that's going to be the angle with the horizontal. And now the question is, how high is the kite above the ground? So here's the angle that we're given. This right here has got to be the hypotenuse. And the height here is opposite the angle. So that's our opposite side. And then this one right here along the ground is our adjacent. But again, I'm not being given any information about it. I'm not being asked anything about it. It's not really all that important. So what's important here is I'm looking for the opposite side, the height, and I have the hypotenuse. So what trig ratio relates the opposite and the hypotenuse? Sine. So the sine of 75 degrees, when I enter that in the calculator, that will tell me what the ratio of h to 150 should be. That should be equal to h over 150. And I will plug that in just a second. First of all, though, I'm going to solve for h. I'm just going to rearrange this. So 1 times h is h. 150 times the sine of 75. Now I'll go to the calculator. 150 multiplied by the sine of 75. Okay. Press enter. And what is it, to the nearest? Oh, to the nearest meter. Okay, well, to the nearest meter, that's 145 meters. So the kite is 145 meters up. All right, here's an interesting question. And unfortunately, a question like this, if I kind of just left people to do it, if I just gave this to you right now, a whole lot of people would get this wrong. And it's for a very, very simple reason that you get it wrong here. You would just read over a little fact that got thrown in here. I'll show you what it is in just a second here. It says a peregrine falcon has built a nest on the ledge of a building in Calgary. The ledge is 34 meters from the ground. Okay, so right here, here's where the nest is, 34 meters from the ground. Now Elaine wants to take a photograph of the bird with his telephoto lens. So he set up a camera and is waiting for the bird to return. His camera sits on a tripod 2 meters above the ground. The angle of depression from the nest to Elaine's camera is 28 degrees. So this is 28 degrees. Now, think about it like this. That's this triangle right here that we're building. Angle of depression, whoops, is from the horizontal down. So there's my 28 degrees. The question is, how far does the tripod and the camera from the building to the nearest tenth of a meter? Well, let's take a quick look at this. Now, so here's the 28 degrees. That's the angle that's important to us. We don't know really anything about the hypotenuse. That's okay. We are looking for this length right here. How far away this tripod is from the building. Now, I could have done this one right here. I'm actually choosing to use this triangle right now on purpose because I want you to notice where that triangle tip is. And I think it's going to be more clear if we look at it right here. So we already know the bird's nest is 34 meters up. Yes, but that's not the length of this side because that camera is 2 meters up. Okay, that little point here, where that hypotenuse meets with that vertical line is not on the ground. It's 2 meters up on that, at that camera. So this is actually 32 meters. Okay, and you have to see that before you can answer this question correctly. That's the little detail here, is this little 2 meters. That's the detail that most of the time people are going to gloss over here. So now, bearing in mind that this is the angle that I'm given here, this is the side opposite, this is the side adjacent. I don't really care about the hypotenuse. So what trig function relates the opposite and the adjacent? The answer is tangent. So the tangent of 28 degrees is going to equal the opposite 32 over the adjacent, in this case x. Whoops, in this case x. Now, I will enter that into the calculator in just a second here. First of all, let's just manipulate this to solve for x. And so when I cross multiply here, I'll get x times the tangent of 28 degrees will equal 1 times 32, or 32. And so x will equal 32 divided by the tangent of 28 degrees. Okay, I can just go to my calculator to evaluate that, because now's the time. 32 divided by the tangent of 28. Okay, and we get 60.2. I think they're to nearest tenth of a meter, yeah. So 60.2 meters. So the camera is 60.2 meters from the wall, or from the building, I suppose we should say. And that's what they're looking for here. Again, you make sure you read the question carefully so that you understand the scenario before you just jump in and grab out that triangle, because it's very likely that what would have happened here is people would have just used 34 as the height, and then your answer would be close but not quite correct. So in this question we read that from the top of a 30-meter lighthouse, a boat is observed at an angle of depression of 27 degrees. Now remember, the angle of depression is from the horizontal down. So there's my 27 degrees here. We want to determine the distance that the boat is from the lighthouse. So this is very similar to the previous question, except it is in some sense just a little bit easier because there's none of that additional bit of information that you need to solve this. So now what I would do is I would just come across and I would just drop this altitude down right here. Okay. The lighthouse is 30 meters high. It's going to be 30 meters. That length of that side right there is going to be 30 meters. And what we're interested in is how far away it is from the base of the lighthouse. So we're looking for that distance right there. So here's the angle that we're given. That's the one that's important. So how does that help us define the sides? Well, this is the hypotenuse. It's opposite the right angle. The adjacent side, when it's paired up with the hypotenuse, creates that angle. So there's the adjacent side, and this is on the opposite side of the triangle. So there we go. Now, what trig function relates the opposite and the adjacent together to that one? Well, it's tangent. So the tangent of 27 degrees, okay, that ratio is the same for every right triangle that has a 27-degree angle in it. The ratio of the opposite and the adjacent will be the same, and in this case it's going to be 30 over x. Okay, so now all I got to do is rearrange this expression for x, and I have done this repeatedly by making that trig function into just a rational expression over 1, and then I cross multiplied, so x multiplied by the tangent of 27 is going to equal 30 times 1, or just 30. So x will now equal 30 divided by the tangent of 27. Okay, so 30 divided by the tangent of 27. Okay, and we get 58.9. Okay, to the nearest meter. Okay, so 59 meters. So x is equal to 59 meters. Not degrees. Not degrees, meters. So the boat is 59 meters from the lighthouse. All right, there you go. Okay, now in this question we read that the base of a ladder is on level ground and is 1.9 meters from the wall. The ladder leans against the wall, and the angle between the ladder and the ground, so that's down here, is going to be 65 degrees. So there's a couple questions they're asking us here. We're going to have to figure out both of them here. First of all, we want to figure out how far up the wall does the ladder reach. So let's call that y. And bearing in mind that this is the angle that we're given, so that's the one that's important here, how does that help us label the sides here? Well, the ladder itself sits opposite the 90 degrees, so that's the hypotenuse. The y here is opposite the 65 degrees, so it's going to be the opposite side here. And then the 1.9, because that side is being used to build the angle, that's the adjacent. So we're asked how far up the wall does the ladder reach? Well, I'm looking for the opposite side, and I know the adjacent side. Okay, so that's the tangent ratio. So the tangent of 65 degrees is, okay, remember that that's going to be the same for every triangle that has a 65 degree angle in it, every right angle triangle I should say. That ratio is always going to be the same, and the calculator knows what it is. So that will be the same as y over 1.9. Now I will evaluate the tangent of 65 in just a second here, but first of all I'm going to get the y by itself algebraically. So 1 times y is y, and that'll be 1.9 times the tangent of 65 degrees. Now I'll just go to the calculator and figure out what that is. Whoops. So 1.9 times the tangent of 65. Okay, so to the nearest tenth, this ladder extends up 4.1 meters. Okay, so it reaches 4.1 meters up the wall. Now the next question is, how long is the ladder? Okay, well that's the hypotenuse. Let's give it a variable. Let's call it, well, I didn't use x, let's call it x. So the labeling is still all the same, it's just that now our focus is a little different. Now I'm interested in the hypotenuse and I have the adjacent side. Now, yes, I do know what the opposite side is right now, it's 4.1. But I would be smart to not use this just in case I made a mistake here. So as long as I don't need to know what that side is, I shouldn't use that side. So let's just look at this, the adjacent side and the hypotenuse, and think what ratio does that imply? Yeah, cosine. So the cosine of 65 degrees, in this case is going to be 1.9 over the hypotenuse x. Okay, so the calculator already knows what that ratio is, and I'll get to that in a second. We'll make this over 1 first, because I got to solve for x. So I'll cross multiply. X multiplied by the cosine of 65 will be 1 times 1.9, so there we go. So x is 1.9 over the cosine of 65 degrees. Okay, so let's go to the calculator, see what that is. So 1.9 divided by the cosine of 65. And we get, to the nearest tenth here, 4.5. 4.5 meters. So the ladder is 4.5 meters tall, or long, whatever. Okay, so this question says that the string of a kite is 160 meters long. The string is anchored to the ground Now, the reason why they say that is so that you don't have to worry about the height of the child or whoever's holding it affecting the height of the kite. The kite is 148 meters in the air. At what angle does the string make with the ground? Basically, what's the angle of elevation of the kite? Okay, so we are looking for this angle down here, so that helps us define a few things. First of all, we know that this is going to be the hypotenuse. This is the side opposite the angle that we're interested in, and this is the side adjacent to it. Okay, now, I have got the opposite and the hypotenuse. What I'm looking for is that angle. Okay, if I knew what theta was, then the sine of theta would be the ratio of those two sides. Now, in this particular case, though, I don't know the angle, but I do know the ratio of those two sides. So what I'm going to do here is I'm not going to use sine, I will use the opposite of sine. So 148 over 160 in the inverse sine. So second sine 148 divided by 160, and we get to the nearest degree 68 degrees. Okay, so then we can answer here the angle of elevation of the kite is 68 degrees.